One way of characterizing a compound is by determining its formula weight. Now, the formula weight, also known as the molecular weight, is the sum of the atomic weights of all of the atoms in its chemical formula. If you were to determine the mass or the weight of a bicycle, you could weigh the seat, and you could weigh the handlebars, and you could weigh the spokes, and you could weigh the tires, and add all of those masses together, and you would get the weight of the bicycle. This is no different. In order to determine the weight of a molecule, then you're going to add up the masses of all of the atoms that make up that molecule. So, for example, sucrose, the chemical name for sprinkle sprinkle on your cornflakes sugar, has a chemical formula of C12H22O11. 12 atoms of carbon, 22 atoms of hydrogen, and 11 atoms of oxygen. If we were to determine the formula weight of sucrose, then we'd have to take into consideration the masses of all 45 of those atoms. 12 carbon atoms, each of which on average weighs 12.011 atomic mass units. 22 atoms of hydrogen, each of which on average weighs 1.0079 atomic mass units. And 11 atoms of oxygen, each of which has an average mass of 15.999 atomic mass units, gives us a total of 342.2948 atomic mass units. Now allow me to ask you the trickiest trick question I'm going to ask you all presentation. If I were to ask you, is a molecule of sucrose made up mostly of carbon, hydrogen, or oxygen? Based on the number of atoms, you would likely say hydrogen, because there are 22 atoms of hydrogen out of a total of 45 atoms. But if you'll notice, the mass of hydrogen is very, very small. So while hydrogen makes up the greatest number of particles, it doesn't make up the greatest in terms of mass. To do that, we employ a technique known as percent composition by mass. We can determine the percentage of a particular compound that is an element by using the following equation. The element in question, let's call it element X. If we want to determine the percent of a compound that is element X, then we're going to take the mass of element X in that compound and divide it by the total mass of the compound. And in order to create a percentage, we're going to multiply that number by 100. A percentage is just part out of the whole. All right. So if I wanted to know how much of a molecule of sucrose is carbon, then I would perform this percent composition analysis. If I wanted to know how much was hydrogen, if I wanted to know how much was oxygen, then I would do this calculation for each of those elements. So when we perform those calculations, we determine that a molecule of sucrose is mostly oxygen by mass. Of the 342 atomic mass units that is a molecule of sucrose, 144 atomic mass units can be attributed to carbon. About 22 atomic mass units can be attributed to hydrogen, and the other 176 atomic mass units worth of mass are the result of oxygen. So performing these calculations, we see that a molecule of sucrose is 51% oxygen, 42% carbon, and about 6.5% hydrogen. I'm going to leave you with a few practice problems for you to take a look at in order to prepare you for ultimately what is to come, whether it be an upcoming quiz or an exam. What is the formula weight of ammonia compound with the chemical formula of NH3. What percentage of a molecule of ammonia is hydrogen and what percentage is nitrogen? And finally, glucose is mainly made by plants and most algae during photosynthesis from water and carbon dioxide using energy from sunlight. What is the formula weight of glucose, given that its chemical formula is C6H12O6?